In this video, we'll go from data disaster to data master. We're going to learn how to build and subset data sets. We're going to learn how to load messy CSV files or Excel spreadsheets and put them in a data frame in R. We're also going to avoid path nightmares and fix common file errors. Why should you trust me? My name is Bogdan Popescu, and I'm an assistant professor at John Cabot University, Rome. I also used to teach at Oxford and at Princeton, and I have years of experience teaching undergraduate and graduate students statistics. Stick around and you'll learn the essential skills in order to build and write your own paper using quantitative methodology. Okay, so today we're covering working with data in R. We're going to look at data frames, we're going to look at lists, how to deal with external files, and how to set up paths. We're going to specifically look at how to create and subset data frames, how to load CSV and xlsx files, the distinction between relative versus absolute paths, how to handle directory errors, and how to examine the entries within a data frame. Before we get into this, let's first create a Quarto document, a new Quarto document. So after you open R, this is what your R interface should look like. We click on File, New File, Quarto document, and we create a new Quarto document that we are going to call Note. This is what it looks like once we create it. We're going to switch to source. So we're going to click on visual so that our final Quarto document looks like this. We're going to press Command A or Control A to delete everything. And we are going to, so our initial blank slate, empty slate is going to look like this. So then we're going to type this preamble. If you click on the lecture slides, if you click on this button, this is going to automatically copy the information here. So if you do that, you can simply paste it right at the top. So notice that there is no space between the three dashes and before. So this is line number 1. You have to make sure that this is the same. And then no space between embed and line number 12. This is crucially important because R is very sensitive to the way we defined our preamble. So once we do this, we can finally save it. This floppy disk is the symbol that allows us to save our Quarto document. Save it in your working directory. So in my case, it's example. I'm changing the names from untitled to notebook, and then save it. So notice now that the notebook QMD, so from untitled, it changed to notebook.qmd. This is what the rendered document looks like. So if we press render, this is what we should be able to see in Safari or Edge. So we just see the title, the notebook, and the author. Okay, the first thing we do, we add a chunk. Just as a reminder, if we click on this green symbol, this is going to allow us to choose among different programming languages. In this lecture, we're dealing with R, so that we're going to choose R, which is going to give us this gray section, which is called an R chunk. Okay. Notice that the R chunk starts with 3 apostrophes and it ends with 3 apostrophes. So make sure that you always open and close them. This is how we write text outside of the chunk. So we have here a section header that's marked with a hashtag and a space, and then the text itself. Obviously, you can write whatever you like here. If we render this document, this is what this would look like. Notice also that the header also appears in the table of contents. Okay. This is exactly what I wrote here, that you have to have a space between the hashtag and the information in the header. So this is what is going to allow the header to appear in the Quarto document. Okay, let us create a data frame. So we're not starting with loading a data frame, but let us just create our very own data frame. So we have 2 vectors. One's one vector that has names, so these are strings, and then one that has numbers. So this is student's grade. Okay, let us create a data frame. The way we do this is by writing data.frame, and we have students equals students, and then we have grade equals grade. So this is going to produce a df, a data frame called df, that looks like this. We have a variable that's called student, and we have another variable that's called grade. Okay, this is what this looks like in our Quarto document. So we have this data frame, and then the df appears here. Okay, so notice that we have 7 observations and 2 variables, student and grade. Okay, so we can also investigate these if we click on this table symbol. If we click on that, this is going to allow us to see this table in a tabular format like this. So this corresponds exactly to this. So the 77 appears here at the beginning, 81 second, 89 third, and so on and so forth. Okay. The df is called a data frame. Student and grade are variables within that data frame. So here's another picture of this. df appears here at the top. df appears in the global environment. df also appears here. So the df is the data frame. Student and grade are variables, right? Okay, this is how we can select specific observations by subsetting our data frame. So we say subset df from the column student, select only Alex, Jane, and Turner. If we do this, we're going to end up with a new data frame that's called subset df that only has 3 rows as it's visible just here. So this is what this looks like what this should look like in our Quarto document. Once we do this, notice that we have a new data frame that has only 3 observations as opposed to 7, how many we had at the beginning. Okay, so our new data frame looks like this, right? Subset df as opposed to just df. So here, this is what we just created. So from student, select Alex, Jane, and Turner. Here they are. So from the original data frame, only select those 3. So notice once again that we have originally 7 observations, and then now we have 3 observations. Okay. Notice also that these data frames here in the global environment are also reflected here as tabs. This is after we click on these table icons. So df has 2 variables, student and grade. Here they are. And then the student and grade are variables. The data frame name is df. The same thing with subset df. So the data frame is called subset df. Variables are the same because we extracted them from the original data set. Okay, let us look at some summary statistics. This is how we calculate the grade. So we take from the data frame, remember that the $sign is really the thing that allows you to extract the variable from the data frame. So from the data frame df, take the variable grade and calculate the mean. The mean for the variable grade is 88.28. We can also do the mean just for the 3 observations that we extract. So this is going to be 85. So originally we had 7 students, and the subset with 3 students is 85.66. This is how we calculate the maximum grade by just simply writing here max. This is how we get the minimum grade. And this is how we can find the students with those grades. So for example, if we say, I want to know who is the student who got the best grade, right? So max grade. So we say df grade. So in the data frame df, in the column grade, which is equal to a number, so we're going to have a specific number, let's say 99, plot or print the student name. So the student who got best grade is Turner. If we look at who got the lowest grade, so here's where we have min grade, we can write df student, df grade equals min grade. We notice that we have Alex. So once again, this is a form of subsetting where we say from the data frame df, from the column called grade, extract that number that's the maximum grade, and then print out the student name. That's how this works. We could also index or operate with indices within lists. So let's imagine we have this vector with this string elements. This is how we get the second element. So the second element will be L2 because L1 is the first, L2 is the second, L3 is the third. So when we say list new square bracket 2, this is going to print out the second element. Okay, how do we get the last element? The easiest way to do that is to, first of all, establish how many elements we have in that list. So if you remember from before, length is really the function of the command that allows us to identify the size of a vector. So this is going to give us 3 because it's made out of 3 elements. So if we say list new, because this is going to be equivalent, so the value of this here is going to be exactly 3. This is exactly going to give us the third element, L3. Okay, so this is essentially this way of operating with lists means operating with lists using indices. Okay, let us now clear the memory. So this is the command that allows us to eliminate everything that we have from memory to start from a clean slate in R. So this is rm list equal ls. This is what allows us to clear the memory. Okay, so if we do this, when we click the green button, this is going to eliminate all of this. So notice how our environment is now empty. Okay, let us now load external files. So R is very good at loading or operating files like CSV, XLS, TXT, even DTA, so data files. So the point here is to load the file, turn it to a data frame, and then analyze it. Okay, so for these 4 formats, CSV, TSV, TXT, xlsx, these are the most common function. So read.csv, read the lim, and so on and so forth. So feel free to explore what the different options around them are. So let us now just work with these 2 data sets from the UN. So life expectancy and urbanization. So if you click on these links, these are going to take you to a Dropbox link that would allow you to download these data sets directly. Of course, you can have access to them through our World in Data, which takes their own data from the UN. Okay, so if you click on these links, these are going to take you to my own Dropbox account, which will allow you to download these data sets. Okay, so this is what your working directory should look like. This was a very specific situation for me. I strongly encourage you to have your own work folders. So in this case, I have week 2 lab data, and then this is where I placed the CSV files. These are the types of documents I work with. So the easiest way to make sure that you get the path to the file correctly is to use this file choose option. So this file choose option allows you to manually interact or to interact with the interface directly. So file choose. So if you do this and you print file path, this is going to allow you to load manually the data set. And the reason why this is helpful is because if you do this and you select it correctly, this is going to print out exactly where your file is. So this long thing here is really what allowed me to figure out the path for my own file. Okay, so if we do this, let's analyze that path a bit. So this section here, this is something that will differ from computer to computer. In fact, the whole path is likely to differ, but this is like my own computer, right? So yours, especially if you're dealing with a Mac, will be different. And then notice that this is more or less the structure of where I place the CSV files. So this is between forward slashes. This is the first folder. After the second forward slash, I have my second folder. Within my second folder, I have a third folder called data. That's also after forward slash. Finally, I have my file just here within this folder. So this is more or less the hierarchy of folders. So I have week 2, I have lab, I have data, and then I have the CSV file. Okay, so this is the part that will differ from computer to computer. This part should be the same, not necessarily here. I used this example previously in a lab that I covered in week 2. This doesn't necessarily have to be the case for you. And then this is the CSV file. Okay, so once we do this, we no longer need to use this open path, this file path option, and we can just directly use the path in this way. So we have the object called path data, assignment operator, and then just a simple string that reflects the first part of the path, and then path data to the CSV file. So this is called a relative path. So once again, we have this path all the way to data, so not entirely. We assign this to an object called file path, which we have here. And then the CSV file comes all the way at the end. Okay, so once again, this is week 2 lab data, and then the CSV file comes second. Okay, then we are doing the same thing for urbanization, right? So we no longer have to write the full path. We just have path data because ideally the CSV file should be in the same folder. So this is what is called the relative path. So it's relative because it's relative to this. So relative to this path data. And then we simply read the CSV file. And then this is different from an absolute path that looks like this, right? That looks like exactly the entire place where you can find the CSV file. You can work with relative paths or absolute paths, whatever works for you. As you might imagine, the relative path could be more economical because you can just write this long path at the very beginning, and then afterwards for all the different data sets that you're working with, you can just write the path more efficiently or quicker. Okay, one common error is this: no such file or directory. And when you see this error, this means that you have not specified the path correctly. So this means you have to go back and try to figure out where exactly the path is. Open path is probably the easiest way to get your file to open. Okay, so if you get that error, just do file choose and repeat the steps. Okay, so now we have life expectancy. Let us have a look at what it looks like. So we uploaded both life expectancy, notice it in memory here, but also urbanization. So this is what life expectancy looks like after we click on the table symbol. So we have entity, we have code, we have year, and we have life expectancy. So life underscore expectancy underscore df is the data frame. This data frame has these 4 variables. And then we have 20,445 observations within our data frame. So the reason for this is because we have multiple countries over time. Okay, let us look at urbanization as well. Here too, we have a data frame that's called urbanization_df. We have 4 variables and we have 14,021 observations. Okay, this is how we examine the first entries in our data. So head, life expectancy _df, n equals 5. So as you might guess, this prints out the first 5 entries in our data frame. If we do head urbanization, n equals 5, this is going to print out the first 5 observations in our urbanization data frame. Okay, installing packages in R. So here's, for example, tidyverse. We have to do install dot packages parenthesis quotes tidyverse. But it's important that once we're done with this, it's important to delete this install.packages tidyverse, because otherwise we will not be able to render the Quarto document, right? So make sure you either delete what you just installed, because this is going to be installed on your machine forever, or add a hashtag in front of it. This is going to comment out the this code. Okay, so once you have it, it will always be there. Once you have the package, it will always be there, so you don't need to install it anymore. Okay, if you get an error, something like this, error in library pillar, there's no package called pillar, this means that you haven't specified the name of the package correctly. So you have to make sure that is indeed the name of the package. So in this case, I just installed it using quotations. So once I did this work, so once again, either comment it out or delete it. So comment it out by putting the hashtag in front of it, or just delete it completely. Okay, this is how we load libraries. We simply do library quote pillar in this case, but obviously others will work too. So you need to load this package in order to be able to use its functions. Okay, so the reason why I used pillar is because I want to use this function called glimpse. Glimpse is a specific command within pillar, which allows me to glimpse the data, to have a quick glance the data. So this allows me to see, for example, that I have 20,445 observations, 4 columns, and it also tells me the types of data that I'm dealing with, so the type of variables that I'm dealing with. Entity and code clearly character variables, meaning string variables, whereas year and life expectancy are numeric variables. So these reflect the years, and these are actual life expectancies. Let us quickly look at life expectancy too. Sorry, this is the same thing. The point of this is to show that you can also access specific functions within a library by doing this. Pillar, semicolon, semicolon, glimpse, right? This, for example, would be possible even without loading the library. So this allows us to get exactly the same thing. Okay, so this is just repeating myself. Entity is a string or character variable. Code is a string or character variable. And the other two are numeric or double precision variable. These are both numbers essentially, but DPL is a specific type of variable that are labels as double precision variable. Okay. So we have learned quite a few things today. So we learned how to create and subset data frames. We learned how to load external files, specifically CSV files. We also learned the distinction between relative versus absolute paths, how to handle directory errors, but also how to examine the entries in a data frame. Thank you and see you very soon. I hope you enjoyed this video. If you found it helpful, please give it a like and press subscribe. Also, if you have any questions or comments, feel free to leave a comment down below. Thank you and see you in the next video.